Chapter 7.1, 0 and negative exponents. When you raise a number to the power of 0, you get 1. But you can't raise 0 to the 0. That's undefined. In calculus, when you deal with limits and limit notation, when you raise to infinity or negative infinity, you can't do it. But in an algebra setting, basically the short version is you take a number, whatever it is, and you raise it to the 0 power, you get 1, provided you pay attention to this. And then we're going to deal with some rules relating to negative exponents. So, okay, I just said this. Okay, now we're going to do some examples. So simply, if you say 2 to the 0, you're going to get 1. You say 3 to the 0, you're going to get 1. You take a half to the 0, you get 1. But 0 to 0, you can't do that. Okay, negative exponents. Well, if you have something like m to the second, it's just m to the second. Or let's put a number there. Let's say it's 4 to the second, that's 16. But if you have m to the minus 2, that's not negative like the value of this thing is negative. It means it's to a negative exponent. That means, pretend it's over 1. This, because you can divide anything by 1 and it's still itself. If you have a negative exponent, this is going to move down. So you're going to get m to the second. You assume that it's multiplied by 1 in the front. So then the fraction, in a sense, it flips. Okay, over here, 4 to the negative 2. Well, pretend it's over 1. This is going to go to the bottom. It's going to turn into 1 to the 16th. 4 times 4 is 16. So it flips. Okay, raising a number to a 0 power. Hang on one second. Raising a number to a negative power. So let's come up with some examples just for fun. So let's see, if you do 9 to the negative 2. Well, we all know that 9 squared is 81. Well, if it's to the negative 2, this goes to the bottom of the fraction. And you can say, well, wait a minute, there is no fraction. Well, divide it by 1. So now this means it's 1 over 9 squared, which is 1 over 81. Let's see, if we put a negative number, let's draw a line across this. If we take negative 4 and all of that to the negative whatever 3, then this negative, that negative, they have nothing to do with each other. What you do is pretend it's over 1, flip it, you have negative 4 to the negative 3. Whoops, now a positive 3 because it's moved down to the bottom of the other side of the fraction. And so now you've got negative 4 times negative 4 times negative 4. So that's 4 and 4 is 16 times 4 is 64. So it's 1 over 64. See, it's not a negative value for an answer. That's a negative exponent. Oh, wait a minute. Negative to the third. Negative times a negative times a negative. Yep, negative. Okay, we're going to move on to simplifying rational expressions. So, whoops. So let me just make up something. So if we say, I don't know, 8x to the second, I don't know, y to the negative 3z. Well, as I said before, just pretend all this is over 1. Wherever you see a negative exponent, move that down. And then it becomes positive. So see, 8 is already no negative exponent, so just write the 8. X to the second, leave that up at the top. But this y to the third, move that down to the bottom. And from moving from one end of the fraction to the other, the sign changes of the exponent. So it becomes y to the positive 3. Z to the first stays in the top. Now, let's just write something else just for fun. Negative 5 x to the third. Let's put y to the second down here. Z to the, oh, let's make it a negative 2. And for fun in the front, I'll put a w to the negative, negative 1. Okay, so now these negative signs for the exponents have nothing to do with this negative relating to this coefficient in front. Two different issues. So look, everything that's got positive exponents, we're just going to rewrite it. So you got a 5, you got an x to the third, we've got a y to the second down the bottom, but everything that's got a negative exponent, we're going to move it to the other side of the fraction. W is coming up, z is going down. And then we really, in standard form, should write this in alphabetical order. So negative 5, w is before x, so just write a w. We don't need to write the 1 for the exponent because that's assumed. X to the third, and then let's see, so you got y squared z to the second. Okay. Okay, we're going to evaluate a rational expression, and once again, I'm just going to make up something. So let's just say, I don't know, let's say we've got 7 x to the second y to the negative 3, and we're going to say that x is equal to 4 and y is equal to, let's say, 3. Okay, so, well, that really means you've got 7, and then x to the fourth is going to be 4, and then this is squared, and y to the third is going to be y, whoops, that would be this 3 to the negative third there. Now that means this part here, not the whole mess, just this. This is the x, this value to the negative third power is just this 3. That's going to go in the bottom, 3 to the third, and then all this stuff at the top stays there. So 4 to the second, well here I'll just write it, 4 to the second, so that's cool. And then as far as numbers go, you know, then you got 7 times 16 over 3 to the third is 27. And there's no let's see, that's 3 to the third, there's no factor 3 there, no factor 3 there. So that's just going to be 112 over 27. Let me write that. 112 over 27. Okay. This is a lesson on exponential functions, negative exponents and zero exponents. We're right now in the middle of coronavirus. It's an exponential function. I don't mean to sound alarmist, but this very much applies to our lesson today. An exponential growth function is going to be an initial population, so population, initial meaning at time 0, times your growth factor raised to the increment of whatever it's growing at. So let's look at the word problem that's in front of us. I just grabbed this off the internet, off of CNN just now. This graph to the left is a logarithmic presentation of the growth of coronaviruses reported in New Jersey as of right now from Johns Hopkins. Believe me, this is a logarithmic. This is flattening it out. If this was a regular viewed graph without any change, this would look much more like that. But you know, it's scaled back. So let's work with what we got. Right now, at this moment, it says we've got 25,590 cases of coronavirus. That would go for here, the initial population, 25590 times whatever it's growing by. We'll see right here in this word problem, it says it's doubling. That's going to be your K value. So that's going to be 2. Now, it says it's every 4 days. So let's convert this into a way of dealing with this math problem in days. So that means it's going to be, well, over here it'd be time, but over here let's make it time divided by 4, because that means that 4 days have to go by before you hit that increment of a doubling. So just arbitrarily, we're now in March 4th, for March 2nd, excuse me. Let's say, what's it like 1 month from now? And just to make the numbers easy, let's just use the number 32 days for a month, because then the math comes out pretty, dividing by 4. So that means you're going to have 25,590 people that are infected. You're doubling it, and you're doubling it every doubling it every 4 days, and we're going to arbitrarily decide 32 days. Okay, 25,000 people being affected by a disease is a huge deal. What is even more startling is to think in terms of what happens over here, this doubling. 32 divided by 4 means that there's going to be 8 doublings of that value in a month. So that's going to be 2 really to the 8th. Well, 2 to the 8th is going to be 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, 7, 8. 2, 1, 2, 3, 4, 5, 6, 7, 8. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256. This is going to be 256 times 25,590 in just a month, according to that projection. Well, that number turns into 6551040. That's 6,551,040 people. That's at this growth rate. So obviously it's growing fast now. And I don't even know if there's 6 million people in New Jersey. But the point is that it's growing fast now. That's what all this social containment is. This is why we're staying home from school, is to cut that growth down.